Possible reasons for ground wire overheating include firstly a defective pedestal. The pedestal may have a faulty internal connection that is causing excessive resistance and heat build-up in the ground wire. Secondly, a loose connection could be the culprit. Despite an electrician's attempt to tighten the connection, it may still be loose or corroded, resulting in high resistance and heat generation. Thirdly, inadequate grounding might be the problem. The ground wire may not be properly sized or connected to a sufficient grounding source, such as a buried ground rod or a cold water pipe. Fourthly, consider an open neutral. If the neutral wire is open, current will flow through the ground wire as a path back to the panel, causing it to overheat. Fifthly, a poorly bonded recreational vehicle panel could be the problem. Although the recreational vehicle panel appears to be bonded correctly, there may be hidden or intermittent connections that are not providing a proper ground path. Finally, a loose hot conductor could cause the overheating. A loose hot conductor can create a high resistance connection that will cause the conductor and any connected ground wire to overheat. The reasons voltage exists only between hot and ground. Firstly, look for an open neutral. With an open neutral, current will flow through the ground wire instead of the neutral, creating a voltage potential between the hot and ground wires. Secondly, there could be an incorrectly wired pedestal. The pedestal may not be wired with the neutral conductor, or the neutral may be broken or improperly connected. Next steps involve firstly disconnecting power to the pedestal and recreational vehicle. Secondly, inspect the pedestal for any visible defects or loose connections. Thirdly, check the tightness of the ground wire connection at both the water main and the pedestal. Fourthly, measure the resistance between the ground wire and a known good ground source, such as a buried ground rod or cold water pipe. Fifthly, check the neutral wire for continuity and ensure that it is properly connected at the panel and recreational vehicle. If the issue persists, consult with a licensed electrician to further troubleshoot and resolve the problem safely. A hot ground wire indicates that the ground wire is acting as the current carrying conductor. This is very dangerous and should be addressed immediately. The fact that it got so hot that it caused a fire indicates that there is a significant amount of current flowing through it. Firstly, the missing ground wire from the main disconnect to the pedestal is a major safety issue. This means that there is no proper equipment grounding path back to the source. The ground wire at the pedestal that is bonded to the water main is likely acting as the only ground path, which is not designed to carry fault current. The illegal tap-off of the 30 amp 120 volts pedestal to supply two 15 amp 120 volt circuits with a shared neutral is also a potential problem. This could be overloading the neutral conductor and causing current to flow through the ground wire. The fact that you are getting 120 volts from the hot to neutral and from the hot to ground indicates that the circuit is energized. The absence of continuity from the ground to the hot or neutral and no voltage from the neutral to the ground suggests that the ground wire is isolated from the neutral. This is consistent with the scenario where the ground wire is carrying current due to a fault. Some possibilities to explore include firstly, an open neutral. If the neutral conductor from the pedestal back to the main disconnect is broken or disconnected, the current will try to find an alternate path back to the source. This alternate path could be through the ground wire, causing it to overheat. Secondly, a ground fault could be happening. There could be a ground fault in one of the 15 amp circuits that are tapped off of the pedestal. This means that the hot conductor is coming into contact with a grounded surface, such as the metal frame of the recreational vehicle or the water pipe. The fault current would then flow through the ground wire back to the source, causing it to overheat. Thirdly, there could be an overloaded neutral. The shared neutral for the two 15 amp circuits could be overloaded, causing current to flow through the ground wire. This is more likely if the two 15 amp circuits are heavily loaded and the loads are unbalanced. Fourthly, there could be a high resistance connection. A loose or corroded connection in the ground wire or at the water main could create a high resistance point. This would cause the current to generate heat in the ground wire, potentially leading to a fire. Some steps to take to troubleshoot include firstly, turn off the power. Immediately turn off the power to the pedestal to prevent further damage or injury. Secondly, inspect the wiring. Carefully inspect the wiring at the pedestal, the main disconnect, and the recreational vehicle for any signs of damage, loose connections, or corrosion. Pay close attention to the neutral conductor and the ground wire. Thirdly, check the neutral conductor. Use a multimeter to check the continuity of the neutral conductor from the pedestal back to the main disconnect. Make sure that there are no breaks or disconnections. Fourthly, test for ground faults. Use a multimeter or ground fault tester to check for ground faults in the 15 amp circuits. Disconnect each circuit one at a time and test for continuity between the hot conductor and ground. Fifthly, measure the current. Use an amp meter to measure the current flowing through the neutral conductor and the ground wire. If the current in the ground wire is significantly higher than expected, this indicates a problem. Sixthly, verify the grounding. Ensure that the ground wire is properly connected to a suitable grounding electrode, such as a ground rod or a cold water pipe. The grounding electrode should be properly sized and installed according to the National Electrical Code, or NEC. Some additional considerations include, firstly, the illegal tap. The illegal tap off of the pedestal is a code violation and should be corrected. It is important to ensure that the wiring is properly sized and protected. Secondly, the recreational vehicle wiring could be the problem. The wiring in the recreational vehicle may not be up to code or may be damaged. It is important to have the wiring inspected by a qualified electrician. Thirdly, the unqualified electrical work could be a factor. The fact that an unqualified person performed electrical work on the pedestal and the recreational vehicle could have contributed to the problem. It is important to only have electrical work performed by qualified electricians. Some final thoughts. The hot ground wire is a serious safety hazard and should be addressed immediately. It is important to identify the root cause of the problem and correct it to prevent future issues. I highly recommend consulting with a qualified electrician to troubleshoot and repair the electrical system. Some additional points to consider are firstly the size of the ground wire. Ensure that the ground wire is properly sized for the circuit it is protecting. The size of the ground wire is determined by the size of the overcurrent protection device, such as a circuit breaker or fuse. Refer to the NEC table 250.122 for the minimum size of equipment grounding conductors for grounding raceway and equipment. Secondly, the type of ground wire is important. The ground wire should be insulated and should be identified as a grounding conductor. The insulation is typically green or green with a yellow stripe. Thirdly, the connections matter. All connections should be made with approved connectors and should be properly tightened. Loose connections can create high resistance points, which can lead to overheating. Fourthly, the location of the ground wire. The ground wire should be run along with the circuit conductors. This helps to minimize impedance and ensures that the ground wire is effective in clearing faults. Some more in-depth details. Firstly, understanding ground faults. A ground fault occurs when an ungrounded conductor, such as a hot wire, comes into contact with a grounded surface such as a metal enclosure or a water pipe. This creates a low impedance path for current to flow back to the source. The current can be very high, potentially causing damage to equipment and creating a fire hazard. Secondly, the role of the grounding system. The grounding system is designed to provide a low impedance path for fault current to flow back to the source. This allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and interrupt the flow of current. This helps to protect equipment and prevent fires. Thirdly, types of grounding systems. There are two main types of grounding systems: grounded systems and ungrounded systems. In a grounded system, one of the circuit conductors, typically the neutral, is intentionally connected to ground. This provides a reference point for the voltage and helps to stabilize the system. In an ungrounded system, none of the circuit conductors are intentionally connected to ground. This type of system is typically used in applications where it is important to maintain a high level of isolation, such as in hospitals or laboratories. Fourthly, ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock. They work by monitoring the current flowing through the hot and neutral conductors. If there is a difference in current, this indicates that current is flowing through an unintended path, such as through a person's body. The GFCI will quickly trip and interrupt the flow of current, preventing a shock. Fifthly, arc fault circuit interrupters, or FSIs. FSIs are designed to protect against fires caused by arcing faults. Arcing faults occur when there is a breakdown in the insulation of a conductor, causing current to arc across the gap. This can generate a lot of heat, potentially igniting nearby materials. The FSI will detect the arcing fault and trip the circuit breaker, preventing a fire. Some code references to consider are firstly NEC 250, which covers the grounding and bonding requirements for electrical systems. Secondly, NEC 300.3, which covers the requirements for running conductors together. Thirdly, NEC 310.15, which covers the ampacity of conductors. Fourthly, NEC 408, which covers panel boards. Fifthly, NEC 550, which covers mobile homes and recreational vehicles. It is always important to consult the latest edition of the NEC for the most up-to-date requirements. Remember safety first. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working on electrical equipment, consult with a qualified electrician. Some general electrical safety tips include: firstly, never overload circuits. Overloading circuits can cause the wires to overheat and potentially start a fire. Secondly, use the correct size and type of fuse or circuit breaker. Using the wrong size or type of fuse or circuit breaker can prevent it from tripping properly in the event of a fault. Thirdly, check cords and plugs for damage. Damaged cords and plugs can be a shock hazard. Fourthly, never run cords under rugs or furniture. This can damage the cords and create a fire hazard. Fifthly, keep electrical equipment away from water. Water can conduct electricity and create a shock hazard. Finally, have your electrical system inspected regularly by a qualified electrician. Regular inspections can help to identify potential problems before they become serious hazards. In the described scenario, the combination of a missing ground wire from the main disconnect, an illegal tap, and a potential ground fault could be contributing to the overheating of the ground wire. It is important to thoroughly investigate the situation and correct any deficiencies to ensure the safety of the electrical system.